The point A has coordinates 0, 1. The line L passes through A and has a slope of a half. Find the equation of L. Just to remind you what the meaning of slope is, if we pick any point on this line, say this point A, and increase x by 1 unit, then y will change by half a unit. If we pick any point at all, if we say pick this point here and increase x by 1, then y will increase by a half. That's the meaning of the slope of a line. The slope of this line is a half. So we need two things for the equation of a line. We need the slope of the line, which is denoted by the letter m, and we need one point on the line. Well, we have the point 0, 1. We label that point x1, y1. Then we write down a formula for the equation of a line. This is sometimes known as the point slope formula, because you need a point on the line and you need the slope. So we plug in a half for m. For y1 we plug in 1. For x1 we plug in 0. So we get this here. Now, normally we don't like fractions, so we multiply both sides by 2 to get rid of this denominator. So we get 2y minus 2, we multiply the left hand side by 2, equals 2 times a half is 1, so we've 1 into x minus 0, or just 1 times x. We can bring everything to one side, that's usually what's done, and we get the equation of the line. Of course, if you want to check this, you could see that the point 0, 1 satisfies this equation. If we plug 0 in for x and plug 1 in for y, we get 2 times 1 is 2, minus 0 is 2. 2 minus 2 is 0. It does check out for this point. And indeed for any point on the line, this equation is satisfied. AB is the diameter of a circle, where B is the point 10, 1. We want to find the center and radius of the circle, and hence write down its equation. So AB is a diameter line. That means that the midpoint of the line segment AB must be the center of the circle. I'll call this center C. So the midpoint of the line joining 0, 1 and 10, 1 is the center, but it's quite easy to actually get the coordinates of the center, because the y values of A and B are the same. The y value of A is 1, the y value of B is 1. So the midpoint of the line AB is just the value midway between 0 and 10. So the midpoint must have coordinates 5, 1. Of course, we could do this more formally by using a formula for the midpoint of a line segment. The formula is x1 plus x2 over 2, comma y1 plus y2 over 2. And so we average the x values. So we've x1 is 0, x2 is 10. So the average of 0 and 10 is 0 plus 10 divided by 2. We just get the mean of x1 and x2. That's 5. And we get the mean of y1 and y2. So we add y1 and y2 together. In this case it's 1 plus 1. Get the mean, divide by 2 because it's two values. So we get 1. So this is the center of the circle. Now how do we get the radius? Well, it's clear that the radius is the distance from the center of the circle to any point on the circumference of the circle. So let's get this distance here. This is the radius. That's quite easy to see what it is in this diagram. It's actually 5. The total distance of A to B is 10. We can see it. We're going from x equals 0 to x equals 10. This is a horizontal line. It's easy to get its length. So the diameter is 10 units. That means the radius is half of 10, which is 5. Now this is the formula for any circle. This comes from Pythagoras' theorem, as was explained in a previous video. So h and k refers to the center of the circle. So h is 5, k is 1. And the other parameter we need is the radius. So the center and the radius is enough to define a circle, to specify a circle. So h is 5, that's the x value of the center. K is 1, that's the y value of the center. And the radius of the circle is 5. 5 squared is 25. So this is the equation of the circle. So I like to do checks. You don't have to do this, but 10, 1 is a point that's on the circle. We can see that. So if it's on the circle, it should satisfy this equation. So in other words, if we plug 10 in for x and 1 in for y and work out all this left hand side, we should get 25. So plugging 10 in for x here, we have 10 minus 5, which we must square, plus y is 1. So we have 1 minus 1 squared, and this should work out to 25. Well, 10 minus 5 is 5. 1 minus 1 is 0. So we get 5 squared plus 0 squared. Well, that's 25. It does check out. And you should see that for point 0, 1. The point 0, 1 will also satisfy this. Let's just do that mentally. If we put 0 in for x, we get 0 minus 5 squared. Well, that's just minus 5 squared, which is plus 25. If we put 1 in for y, we get 1 minus 1 is 0. So we end up getting 25. So these 2 points, A and B, satisfy this equation, as expected. And the same is true for any other point on the circle. If we knew any other point, we could plug it in here and verify that this equation is satisfied. The line L crosses the circle at points A and D. Write down the slope of dB, that's this line here, and explain how you know that this is the slope. Now we use an important theorem here, that is, the angle in a semicircle is 90 degrees. So we have a semicircle here. AB is a diameter, so we have this semicircle here, and this is the angle in the semicircle. This angle is 90 degrees. So what I'm saying is if you take any semicircle, so this line here is a diameter, and this point is the center of the circle, then if we pick any point on the circumference, say this point here, and join it to the end points of the diameter, then the angle formed is 90 degrees. Doesn't matter which point we pick. We could pick a point over here, join the point to the end points of the diameter, and we always get a right angle. So that's an important thing to notice when you see a semicircle. So AB must be a diameter. Can't be just any old chord of this circle. By the way, this result comes from another theorem, a theorem that says that the angle at the center of a circle, standing on the same arc as this angle here, is twice this angle. So you can see that both of these angles stand on this arc here. This arc happens to be a semicircle if the angle at the center is 180 degrees. The theorem says that the angle at the circle is half this angle. So this is the angle at the circle. So if we pick any point here and join down to the end points, we get a 90-degree angle. This angle is half this angle. So if this is 180, then this must be 90. So this theorem here is a deduction from a more general theorem. The more general theorem would involve any arc of the circle. It doesn't have to be a semicircle. So we could have an angle like this. It might be, doesn't have to be 180, it might be 120. Then the angle at the circle, say this angle here, is half of 120, which is 60. Anyway, this is just getting away from the main point. We know that the slope of the line L is a half. We were given that. Then we know that the slope of dB, it must be minus 2. Why is that? Because if we multiply the two slopes together, these two slopes, we get minus 1. Here we've used the fact that L, the line L, is perpendicular to the line dB. Means if we multiply the slopes of the lines together, we always get, for two perpendicular lines, we get minus 1. So if we know the slope of one line, we can get the slope of the other line by just inverting this number and changing the sign. So we invert this number to get plus 2, change the sign to get minus 2.